Good morning, Year 11. Pause the video and play when you're ready to go through the answers. Okay, so for the first one, you should have by now realised that we need to take away the smallest x from both sides. So if we subtract 2x from both sides, we get 5x plus 1 is equal to negative 4. If I then subtract 1 from both sides, I get 5x is equal to negative 5. Divide both sides by 5 and you get x is equal to negative 1. Now this one, I've tried to trick you. That means 3 multiplied by x squared. And when you write it out like this, you know that you need to do the powers first. So we've got 3 times 4 squared. 4 squared is 16. 3 times 16 is 48. Okay, so you must make sure that you're doing BIDMAS. Some of you may have done 3x squared. Okay, so some of you might have done, well, 3 times 4 is 12, and then squared that, okay? So just be careful. 3x squared is very different to 3 lots of x squared. Okay, so for this one, our sequence goes up by 2, then up by 4, then up by 6, then up by 8, then up by 10. So it's increasing. If we find the second difference, it's increasing by 2. So if the second difference is the same, so if the second difference is constant, we call it a quadratic sequence. So something in the form an squared plus bn plus c, where we need to find out what a, b, and c are equal to. So the best thing to do is to circle the left-hand diagonal. And you need to remember these 3 equations. So 2a is equal to 2. 3a plus b is equal to the middle one. And a plus b plus c is equal to the top number. So then we've got 3 equations. If 2a is equal to 2, I can say that a must be 1. So we know it's going to be 1n squared. 3a plus b equals 2. Well, I know that a is 1. So 3 lots of a is going to be 3. So 3 add a number is 2. So b must equal negative 1. So it's going to be minus 1n. A add b. 1 take away 1 is 0, so c must equal 10. And that is my quadratic sequence. What is the interior angle sum of a pentagon? Well, a pentagon has 5 sides. So if we've got a regular pentagon, something that looks like this, okay, so we've got a regular pentagon. The way that you can work this out is if you remember the formula, it's the number of sides, take away 2, multiplied by 180. So if you've got a 5-sided shape, 3 times 180 is going to give you 540 degrees. The other way of doing it, okay, well, if we pick a point here and we join it up with all of the other vertices, then you can see that you've got 3 triangles. That's where the formula comes from. If you've got 5 sides, that's going to give you 3 triangles, which is why it's 3 times 180. There's obviously 180 degrees in a triangle. Okay, right. Today's work is the sine rule. So can you write down the sine rule as your title, pause the video and play when you're ready to go through the examples. Okay, so the sine rule, if I just pause this, if I go to the triangle decision tree, okay, so the first thing that you need to realize when there's a triangle in your exam is it a right angle or is it not right angled? If it's right angled, you've got Pythagoras or SOHCAHTOA, okay, so you've got trigonometry for right angled triangles. If it's non-right angled, you've got 2 options. You've got something called the sine rule, or you've got something called the cosine rule. In today's lesson, we're going to use the sine rule. And in order to use the sine rule, you need 2 angles and 2 opposite sides. That's when we're trying to use the sine rule. So if I go to this one, can you copy these 2 formulas out? So what I would like you to do is to copy this triangle here. So you've got any triangle, I'm just going to talk over it. So we label the angles with capital letters. So we've got A, B, and C in capitals. And then the sides are the lowercase version of the capital. So we've got A here, lowercase a, B here, lowercase b, C here, lowercase c. Now, if we're trying to work out a side, because the sides are the lowercase letters, we put the letters on the top. So can you copy this into your book And can you make sure that you're using that formula for the sides? If you're trying to work out a missing angle, you need the capital letter on the top. So you need to use the formula, which has basically just been flipped upside down. So it's exactly the same thing. A over sine A just becomes sine A over A. But what's really important is that you are making sure that it's sine of an angle. So it always needs to be sine and a capital letter, because as I've said, the capital letters represent angles. Okay, so we're just going to use that formula a bit more in the example. So on the left-hand side, the reason why this is the sine rule is that because you have a side and an angle, so we've got 4 and 36, we have an angle and a missing side, so they can kind of be represented by these kind of two oval shapes. So we've got a side and an opposite angle, we've got an angle and a side. Okay, so what we need to do, I'm trying to work out a length. So actually we only need, for this equation to work, we only need the first two parts. So I'm going to use the formula A over sine A equals B over sine B. Now I can label the triangle as I wish, but it's just the principle that you need to understand. So it's the length divided by sine of its angle. So the length here is 4 divided by sine of its angle. So divided by sine 36 is equal to the other length, which is x, divided by sine of its angle, which is 84. Once we've got this, we can now just rearrange that equation. How do I get x on its own? Well, I need to multiply both sides by sine 84. So I've got 4 divided by sine 36, and I'm just multiplying that by sine 84. Now bear with me whilst I type this into my calculator. So I'm going to write it exactly as I've written it. So 4 over sine 36 multiplied by sine 84 gives me an answer of 6.77 centimeters to 2 decimal places. Copy that down and we'll go through another example after you have done that. Okay, so this one, the reason why this is the sine rule is, again, we've got a side and an opposite angle, and we've got a side and we're trying to work out the other missing angle. Now we are trying to work out an angle this time, so the formula is going to be flipped upside down. So what I'm going to do is sine of capital A, remember it's always sine of the capitals because it's always sine of the angle. So sine A over little a is equal to sine capital B over lowercase b. Now which of the corresponding ones have we got? Well, we've got sine of 18 divided by its length, which is 4, and it's really important that you're making sure you're getting the lengths and the angles the right way round. So just double check. Sine of 18, because that's the angle, divided by the length, which is 4, is equal to sine of y divided by 9. Now this one's slightly hard, okay? So we want to work out sine y. So I'm going to multiply both sides by 9. So if I write that here, I've got 9 sine 18 divided by 4. You could have written it as 9, if I just write it over here, you could have written it as 9 times sine 18 over 4, but you know that 9 is the same as 9 over 1, and if you're multiplying fractions, it just becomes 9 sine 18 over 4. But anyway, back to this question. So we're going to multiply both sides by 9. So you've got 9 sine 18 over 4 is equal to sine y. You should have hopefully remembered, how do you get y? Because that's what we're trying to work out. You need to do the inverse of sine. So you're going to do sine to the minus 1 of 9 sine 18 over 4. So if I just put that answer up here for you, and sorry that it's getting a little bit messy, if I just type that in, so to get sine to the minus 1, I do shift sine. I'm going to press the fraction button. I've got 9 sine 18. Now make sure when you press sine, it will open brackets. You want to make sure that you're closing that bracket, otherwise it won't work. Divided by 4, and then hopefully you should get an angle of 44.05 degrees, 2 decimal places. It's always worth checking. Is that, or does it look right? They're often not drawn to scale, but is that a sensible angle? Yes, it's less than 90 degrees. It is a sensible angle for y. Now, what I'd like you to do is to give the questions on the right a go. Now, I know that the examples are a bit jumbled up on the left. Give it as much of a go as you possibly can. I will then go through them step by step if you are still unsure. Pause the video, play when you're ready to go through the answers. Okay, so we've got a side and an opposite angle. We have a side, or we're trying to work out a side, but we've got its opposite angle. So that's what's telling me it's a sine rule. It's not a right-angled it's not a right-angled triangle. Have I got a side and the opposite angle? Yes. Are we working out a side or a length? We're working out a side. So the formula that I need is A over sine A is equal to B over sine B. And I'm just going to reiterate that it's always sine of the angle. So it's always sine of a capital letter. Now we've got 9 over sine 85. So we've got 9 over sine 85 is equal to my missing length x divided by sine 45. Now to get x on its own, we're going to multiply both sides by sine 45. So I've got 9 over sine 85 multiplied by sine 45. If you type that into your calculator exactly as it is written, bear with me, 9 divided by sine 85 multiplied by sine of 45 is equal to, if I've got this correct, 6.39 centimeters, 2 decimal places. Is that sensible? Well, if that length's 9, that length could be 6.39. That's sensible. So I'm pretty sure that one's correct. For the last one, even though they've written letters, you could just, okay, well, I'm just going to ignore them. You can just create your own letters. It doesn't make much difference. All we're looking at is, have we got a side and an opposite angle? Sometimes they will trick you by putting the letters in the wrong place. That's just not very helpful. So you've got the side and the opposite angle. We've got a side and we're trying to work out the angle. Because we're trying to work out the angle, you're probably screaming at me to say the formula needs to be flipped upside down, which is correct. So we've got sine of capital A over little a is equal to sine of capital B over little b. Now we've got sine of our missing angle, so sine theta over 2 is equal to sine 53.2 over 4.9. We want to work out theta, so the first step is to multiply both sides by 2. So we've got sine theta equals 2 sine 53.2 over 4.9. And to work out theta, you need to do the inverse. So we've got sine to the minus 1 of our answer. If I type that into my calculator, sine to the minus 1 of sine 53.2 over 4.9, I should get an angle of 9.41 degrees. Now, I think that's quite low. So what I'm going to do is I'm just going to check. I've got sine over A, sine B over B, sine theta over 2, that's correct. Sine B over that, that's correct. Multiplied them by 2, that one looks okay. And unless I've typed it into my calculator wrong, that should be the answer. Okay, so unless I'm missing something, that should be the answer. Right, the next question, sorry, the next slide has lots of questions. Make sure you're checking your answers. So a lot of you are submitting your work, which is absolutely fantastic. Make sure you're uploading your work on Google Classroom. Can you also make sure that you're going through the video and checking your answers and marking them in purple pen? So here are the questions. Here are the next set of questions. Here are the answers. So make sure you are marking them, physically marking them in purple pen, ticking or crossing. And if you make a mistake, that you are understanding why. Okay, and now this is a GCSE question. So pause the video and play when you're ready to go through the answer. Okay, so we've got L, M, and N. Now we have got a side and an angle, and we are trying to work out the length of LN. So the length of LN. So this length here. Okay, so how are we going to work that one out? Have I done this one correctly? So we've got that angle and there. We've got this side. I need to work out this angle. Okay, so what are we going to do here? What is the easiest way of doing it? Okay, now I don't know how many marks this question is. However, the way that I think we can do it, and it does seem a lot harder than it should, but if we work out this angle up here, that would give us this one. So what I'm going to say is I'm working at an angle. So sine theta over 12.8 is equal to sine 136 over 15.7. So my angle is going to be sine to the minus 1 of 12.8 sine 136 over 15.7. And my angle, therefore, I'm just going to make sure that I type this in correctly. So we've got 12.8 times sine 136 over 15.7. Angle, I'm not going to round because you never round halfway through the question, but I've got an angle of 34.4957898.5. I'm going to leave all those decimal places in. So that angle there, I'm just going to put is 34 point something. And now what I can do is I can say, okay, well, if that's my angle, if that's 136, I can add those together. So I'm going to add on 136. And I'm going to subtract that from 180. So therefore, this angle here must be 9.504210.148. Now that I've got this angle, what I can do is I can say, okay, well, I've got this pair here. So what I can do, let me see if I can just erase this. I've already got that pair from the original question. I now know what this angle is. So what I can do is I can say, okay, well, I've now got this new pair. So what I'm going to say is I'm working at a length. So I've got x over sine and then this angle, and I'm not going to round it until the very last answer. So 9.504210.148 is equal to 15.7 over sine 136. Multiply both sides by the denominator there, and you'll get x is equal to 15.7. And it's a very long-winded way of doing it, but hopefully you have done the same or you found a shortcut. 9.504210.148 all divided by sine 136, and the answer is going to be 15.7 multiplied by sine 9.504210.148 all divided by sine 136, and I've made the classic mistake and I've not included the brackets, so apologies about me talking through this one again. 9.504210.148 over sine 136. I'm going to make sure I've included the bracket, and I should have got an answer of 3.731885.117. I'm then going to round that to one decimal place. In fact, it says 3 significant figures, so 3.73 to 3 significant figures. And hopefully that is the answer when I show you the next slide. Thank goodness for that. Okay, so I might have done it a very long-winded way. Hopefully you have found a shortcut, but that is the correct answer. Okay, the next few slides have got extra practice questions, so there's no expectation that you complete all of these. If you want some more practice, they are there. At the end of the lesson is the exit ticket though. So if you've done this and you're happy with what you've done, go straight to the exit ticket. Here are the extra practice questions. Here are the answers to those. and then here's the exit ticket. So pause the video and play when you're ready to go through the answers. Okay, we're working out a length. So we need x over sine 54 is equal to 12 over sine 102. So which one is that? C. Okay, the next one. Which of the following is a correct rearrangement of this equation? So they've got a side and an angle, a side and a missing angle. How do you rearrange that? Okay, so to get sine y on its own, you need to multiply both sides by 7. So it should be sine y equals 7 sine 34 over 8. So it should be this one, because you're multiplying the whole thing. So it's going to be D. And then the last one, which of the following is a correct equation based on the diagram on the right? So that's similar to the last question, in that we've got the angle and a side, the angle and a side. We're trying to work out the angle. So we've got sine y over 7 is equal to sine 34 over 8. I believe that the answer is 8. Okay, thanks for listening. I know it was a slightly longer video, and I look forward to teaching you again on Monday. Please do remember to send me your work via the email address in the announcement. Sorry, not the email address, Google Classroom. My apologies.